In this section, we're going to be working with the product to sum and sum to product formulas. The first thing we're asked to do is write the product as a sum or difference. And so we analyze, what do we have here? We have cosine and sine together. And so we're taking the cosine of something times the sine of something, which is going to use the formula cosine u sine v. That's equal to 1/2 times the sine of u plus v minus the sine of u minus v. In this case, u is 6x and v is 2x. So the cosine of 6x times the sine of 2x is equal to 1/2 the sine of 6x plus 2x minus the sine of 6x minus 2x. That's equal to 1/2 the sine of 8x minus the sine of 4x, or 1/2 sine 8x minus 1/2 sine 4x. For part B, we have cosine times cosine. Cosine is going to be the formula cosine u minus v plus cosine u plus v times 1/2. In this problem, u is 4x and v is 5x. That's going to be equal to 1/2 times cosine 4x minus 5x plus cosine 4x plus 5x, which is equal to 1/2 cosine negative x, interesting, plus cosine of 9x. And we can distribute that 1/2. That's cosine negative x plus 1/2 cosine 9x. And cosine's even. The cosine of negative x is just cosine x. So we have cosine x half of cosine x, plus 1/2 cosine 9x. For this question, we are going to use the product to sum formula to find the exact values of 165 and 75. We're multiplying sine times cosine, sine first, then cosine, so that's going to be sine u cosine v is equal to 1/2 sine u plus v plus sine u minus v. In this case, u is 165 degrees and v is 75 degrees. The sine of 165 degrees cosine of 75 degrees is equal to 1/2 sine 165 degrees plus 75 degrees plus the sine of 165 degrees minus 75 degrees. That's 1/2 the sine of 240 degrees plus the sine of 90 degrees. And I'm going to refer to the unit circle to find those values. That's equal to 1/2 times negative root 3 over 2 plus 1. Finding a common denominator, I'm going to have 1/2 times negative root 3 plus 2 over 2. Multiplying through, I get negative root 3 plus 2 over 4. Going from sums to products now, we have two cosines summed together, so we're going to use the cosine x plus cosine y formula. Cosine x plus cosine y is equal to 2 cosine x plus y over 2 times cosine x minus y over 2. And in this case, x is 5x and y is 2x. The cosine 5x plus cosine 2x is equal to 2 cosine 5x plus 2x over 2 cosine 5x minus 2x over 2. Cosine 5x plus cosine 2x is equal to 2 cosine 7x over 2 cosine 3x over 2. For sine minus sine, we're going to use the following formula. The sine x minus sine y is equal to 2 cosine x plus y over 2 sine x minus y over 2, where x in this case is beta and y is 5 beta. Then sine beta minus sine 5 beta is equal to 2 cosine beta plus 5 beta over 2 sine beta minus 5 beta over 2. That's equal to 2 cosine 6 beta over 2, or 3 beta, sine beta minus 5 beta, or negative 4 beta over 2, which would have been negative 2 beta. But this negative means that the entire function is negative. So we have negative 2 cosine 3 beta sine 2 beta. Let's find an exact value rather than just using variables for sine 75 degrees minus sine 15 degrees. We're going to use the sign difference, then sine x minus sine y. That's equal to 2 cosine x plus y over 2 sine x minus y over 2. In this case, x is equal to 75 degrees and y is 15 degrees. Sine 75 degrees minus sine 15 degrees is equal to 2 cosine 75 plus 15 over 2 sine 17 minus 15 over 2. That's 2 cosine 90 over 2 sine 60 over 2, or 2 cosine 45 sine 30. We know that the cosine at 45 degrees is root 2 over 2, and the sine at 30 is 1/2. Multiplying straight across and actually reducing by 2, we get root 2 over 2. Lastly, let's verify this identity. We have a difference of cosine and a difference of sine. So we're going to go from sums or products, or sums to products, or really differences to products, but it's just using a negative. Let's recall the sine and cosine formulas. In the numerator, x is going to be 4x and y is going to be 2x, and in the denominator, x is going to be 2x and y is going to be 4x. We have negative 2 over 2, so that's a negative. The 2's can simplify, they can divide. I can divide the 2's by 2 to get 1's here. I still have a negative. We simplify to negative sine 6x over 2, or 3x, sine 4x minus 2x, or 2x over 2, which is x, over cosine 2x plus 4x is 6x over 2 is 3x, sine 2x minus 4x is negative 2x over 2 is negative x. And a negative sign, when we have that negative input, it makes the entire function negative. So I can make this a positive, but the entire function is a negative, which means that these two negatives actually become a positive. So we have sine 3x sine x over cosine 3x over sine x. I can divide sine x by sine x, and sine over cosine is tangent 3x, and we have verified the identity. And that's it for this section.